Right. So welcome to session 3 of the GIDA Starknet Cairo Bootcamp. And I'm Weber, in case you've forgotten from the last time we spoke. And this session, we're going to be talking about some testing techniques that we didn't consider in the last session, and we're going to be giving some assignments. All right. So I'm going to share my screen now. Can see my screen just anytime. Okay, can you see my screen? All right. Okay. So, yeah. Okay, I'll start with foundry, right? And into the counter contract that we wrote. So we didn't finish writing some of the tests, and I asked you guys to write particular test for me, which is a increase counter test. Right. That is the increase counter test. I don't know if you wrote the test. No, you wrote the test. It's a reaction. Nobody wrote the test. Okay, I'll just close my vscode. I think I'll use custom condition. So yeah, I guess Lamin wrote the tests and Shoma. Right. So moving forward, in the previous class, I had an issue, right? Running my test. I said I would sort it out and reach out to you guys. So yeah, the issue with the test was actually my version of SL Foundry. Right. I knew my version was not updated, but then I couldn't do that in the course. I had to do that. Why is Microsoft not opening? I had to do that off the call and then run the test. I made the GitHub repo available for the previous test just in case you wanted to check it out. So I'm going to be running the previous tests with Git to ensure that those tests pass, and then we're going to be writing the decrease counter tests, and I'm also going to be testing events from the counter contract, and we're going to be learning how to use SafeDispatcher, and then a little introduction to fuzz testing. What fuzz testing is, and I'm going to write like a simple fuzz test. And then I'm going to questions you might have had from the beginning of the session. All right. So yeah, my side is up. Just zoom in a bit more. I think this perfect. Is my screen size perfect? My phone perfect? Right. Proceed. I think this is where it stopped. Okay. Yeah, I also did something. I added the calculator contract to root. Okay, it's not a contract, the calculator program. I added it into this file. So we can easily just use. So this is what we're going to be using later on. You can still take it out and use it separately, but then no problem. So yeah, I think I made one important change to that I have to mention. This is where I just imported my program. So one change I think I made was on the amount in this assertion here, right? In the previous code, the assertion was less than, it was a less than rather than, what is my, the assertion was the less than rather than the greater than, which shouldn't be. Right, so that was like filling the test at some point. So the assertion should be greater than, because if amount is greater than 0, it's supposed to pass. Else, amount cannot be greater than 0. So this is supposed to prevent us from having a negative value in our amount here. So yeah, I don't know if you ran any of the tests, you would have observed that. So just go and do Scarb tests. Let's see if our tests are passing. So if you observe something, she's no longer giving me that one which was given me, because my SFF is now up to date. I'll run that here. And SFF you see a 0.14, right? This is like the latest version. You can see the plugin is also 0.42. There's no like version conflict there. So you just allow that test to run. And if you observe the test, you can see counter unit test. Right? So where this is coming from the counter contract and the calculator contract. So because of this unit test that wrote unit test this contract. This error that my ID is from the Cairo 1 extension. For some reason, the extension has been acting up. I was not be able to like understand. I not be able to like understand the test attributes, no attribute. So yeah, this is actually not an error in the code. It's an error from the extension. I don't know why, but then because you see that test is going to pass, but it's giving this unsupported attribute. All this is actually good code. Is the extension that is giving it. So yeah, what I was talking about was the unit test, counter unit test is this compiling this unit test first, right? And then it's going to compile the execution test in this test contract also. For some reason, my test takes too long to run. But then while we wait for that, we're going to be writing the decrease counter test immediately. So did anybody write the test? I thought you guys were mentioning the test. So anybody that wrote the test, can you share the test with us now? Can you share the test you wrote? I'm not getting any response. So I should just write the test myself. So you want me to just write the test myself? Then it's fine. Which write this? So I'll just comment this out. Okay, somebody's. I think somebody's going to guess.
Sorry.
Yes.
Hey, the test is it the one we wrote for the addition and the rest?
Yes, the decrease counter. Not the addition. I said you guys should write a decrease counter test. Like Lamin wrote a test. So I'm going to use this test. This. Test attribute us again. Simple thing. That's gone. So initial counter of 10, deploying the contract, passing an initial counter, or even the counter dispatcher, and we're cheating the code with the owner as the caller. Then we decrease it by 3. I was supposed to get a value of 7, right? The expected 7 found. So this is Ethereum. Ethereum. Why is this case taking so long? I'm going to test again. I think I am taking this out to probably increase the speed of this because it's not ignoring the tests and it's having to like run every single one of the tests or the unit test, then go again to run the test contract. So yeah, that contributes to what we like slowing down the test. So let's wait a bit and see. Else we'll just cut this file and work with the test contract. Let's do this. Yeah. And whatever is referenced to here. I'm about to just add counter contract. And if the new test, so instead of just switching, I'm going to go switch. So I've been able to write a decrease counter test, and I believe this is very correct. Very correct. So there are other things we can do. We can use the should panic write our tests. Similar things that we have done in the unit tests. We can use those similar attributes, right? In the smart contract tests. For example, we can write a test that we expect to panic. For example, the decrease counter. You know, if we decrease the counter below 0, it's going to panic, right? So we can write a test for that also. This is most have. So I think we should do that. And right. I always make reference to the SM foundry documentation and also the Starknet Cairo documentation. Expected So now, what test are we trying to run here? Because of the tests we're trying to run, is going to determine what is going to be expected. So for now, let's start. Test decrease counter. Same block of code. I just try it now. So you can just copy this. And what else? I copy this, right? And now inside here, we can now write the test to test our decrease counter and expect it to panic. So we're going to be using an initial value of 0 and then try to decrease it below 0, knowing that according to the contract, you're decreasing below 0 is going to cause an error. Right? Each of the assets. So we have to know which of the assets is going to show the error. Because that error we are going to be watching out for. That's the error that's going to be in our panic data, in our expected of the panic. So now save the counter dot read. So this is like the initial value of the counter is greater than 0. So the initial value of the counter has to be greater than 0. Or counter is greater than cannot be less than 0. But in our initial value of the counter is equals to 0. Equal to 0. So it's going to throw this error. Why? Because the initial value of the counter cannot be less than 0. Do you understand? Is anybody following? So the reason why we can't use this data or we are expecting it to panic is because the initial value, which the initial value are going to be reading from the state before making any change, should always be greater than 0, but at least we're starting with 0. So counter cannot be less than 0. Okay. Okay. Now this is a very important use case. Very important use case we're going to be discussing. This just like brought me to the next topic I wanted to talk about, which is safe dispatchers. Safe dispatchers. This was not the test we were supposed to write for safe dispatchers, but then just quickly reminded me of safe dispatchers. So testing event and safe dispatcher. So quickly, okay, let's just change this. Let's keep it simple. Change this to 1. I'm going to do that in safe dispatchers. I'm going to do that kind of test in safe dispatchers. And I'll explain how safe dispatchers work, right? So we can still do this. Well, let's do it. It not look like our test are not wrong. This is very strange. So I've done this test before and the past. So let me try to do Scarb. the cache. Then let's finish this step before I run it again. So yeah, I'm going to be calling, what function were we calling again? The decrease counter function. So the counter dot counter, I'm going to pass the value of 1. Right. So why I was saying we would have just used a different value other than 0, right? Is because now since we're trying to decrease the counter from a value less than 0, right? We expect this to also panic, right? We expect this to also panic, and this also we expect this to also panic. So instead of expecting the testing two panics at the same time, we will just test one assertion, right, and test the other separately. Do you understand what I was trying to do by avoiding trying to assert two panics in the same test? Then you can create a different test for that. But then we're still going to do that. And yeah, we're going to be testing for the first assertion should be the one that would fail first. And we remove all this so we can move around. Not needed. So this is the first assertion, and this is what we're trying to test for. Counter cannot be less than 0. So initiating our counter with 0. Initial counter 0, then we try to decrease it by 1. But if initially, once the code gets to the assertion where the counter is starting from 0, it's supposed to fail. Why am I getting counter ignored like 15 there? Okay, that's gone. So yeah, should panic expecting this, according this. Yeah, and also if you look at this, you are seeing that there's 2 stop to corners, so you can get rid of that. And then next we can run our test.
I didn't know.
We'll have to wait for this test again. And check the one process that is doing this. that, I will try to run this test in the PowerShell terminal. Sorry for all the delay. I wonder why Scarb is missing up. This is one of the reasons why I prefer to use Mac OS for doing stuff like this, because Windows kind of control it sometimes. I really think we should just move on and let the test run. So yeah, I've written the test for the pan this counter function, and then up next, testing events. So I'm going to go to the test to writing test for events. So I'll just waiting. So yeah, events as was saying in the last class is they are like kind of like a feedback that's given to the real world when a function or something happens in your your smart contract. So an event is just like to notify other parts of your system that are integrated with the smart contract that hey, something happened. For example, we wrote events on counter increase. So this event is always going to be emitted whenever we increase a counter. So for example, our front end now that for example, a user tries to increase the counter to try to interact with the counter from the front end. So the only way the user is going to know that the counter has been increased is if the emitted event can be what, like you can observe you can see the emitted event right on the front end. That's the main use of the event. So you can actually test to ensure that these events are emitted. So, and to do that, there's something called the spy event, right? The spy function, right? Let me just go to the, so it is foundry documentation. If you see my screen, you can see there's the part called testing event. And so you can use this documentation as I explained. So they wrote a simple contract. And yeah, for most of it, this is all you need. Just click your assert emitted methods from the spy. And then let's go to our code and implement the same thing. So we'll be naming our test, right? Test, which is counter. Yeah. And then all the same well-updated code that we used before. And just copy that. Deploy our contract, start with an initial counter of 10 and counter dispatcher. So you can interact with the code that the caller address. You know when to stop checking the. And then, yeah, now so the main thing we need for events, right? We need the spy event, which comes from the SF Foundry. Like SF Foundry provides us with that. Can you see this? You can see this very action. It comes from the SF Foundry standard like spy events function, right? You can see that high reaction. Okay, cool. So the spy event, you can come there and paste that. And yeah, so now we have the spy event function in our contract. And we can use that. To use that, we have to compiling after stronger. And so we'll call the spy event function, which returns need to pass it any argument. And if I just control click on this, open up like a little documentation about the code from the SFRG library. All right. I got taking so much time to do it. Okay. It just returns a my network quiet. You actually can go to I think you can hear me. So we get this spy, we assign it to a spy variable, make it a rootable variable, and then the spy variable, you can call, you now get you get access to some functions. But the most important function we're going to be using right here is the spy.assert emitted function. That's function of this we're using. Yeah. So the spy events provide us with this function. But then the only time you can use this is when you want to assert an event is emitted. And before that event has to be emitted, you have to be able to call the function. For example, we are testing the input counter event. So we can just do this, call the counter dot input counter function. Right, let's see, this is like, so now this is where we cannot assert that an event, a particular event is deleted when we call this function. Can you please see a reaction and show? So this is where we can assert that a particular event is emitted, right? Yes, thank you. And how we do that? We pass an array. We initiate a snapshot of an array, right? We pass a snapshot of an array that takes a tuple, right? These are all data structures that you paid for. So a snapshot of an array. So we're using the array marker. It just helps us create an array and takes a tuple. A tuple is just a data type that takes more than one value. Right, that is fixed times. But then a tuple of the contract address that I want to assert from, right? Contract address want to assert. I mean the contract address that's emitting the event, and the event wants to assert, or the event we believe is going to be emitted. So in our case, if event, we can get this event from the event dispatcher. Sorry, from the contract. If you come back here, you see that we made the event a public enum, right? So that exposes it and allows us to be able to use it. Also, apart from that, we also exposed the struct of each event, the public keyword. Also exposed the values of the struct, right? Using the pub keyword. Also, this is very important because this is what exposes this struct and this event to be able to be used in the test contract structure. For example, if we don't expose this with the public keyword, right, we will not be able to use this counter key in the test contract. Right, we'll not be able to use this. So we'll be able to get the counter in key, but we'll not be able to get this counter. Right, so you might face some error like that if you don't expose that in the public keyword. Back to our test event, we have to use an array that takes a tuple of the contract address and the event we want to assert. So from the contract, we imported the contract, right? Which is what's the name of our contract? You can just come here. Okay, we've not imported the contract. So we have to import the contract. Contract is a module, so importing the contract as a module will help us to be able to use big values inside. So now we have the counter module here, and we can now access values inside the module using the this right, counter event, which is the name of our enum, right? And the name of our structure, the enum strata include. Right, are you following? So now we have been able to get missing semicolon feedback. But then one more thing that is left is, if you observe, this is the struct, right? So it's supposed to take a particular value, a key value pair, right? And that's the main thing we're going to be asserting. Because if you come back here, I don't need to follow me. If you come back here, you can see emitting. This is all we want to assert. We want to assert that this is being emitted. So the counter increased event, then the structure of counter increased, and then the counter key and the current value of the counter. So you come back here to emit that same particular thing. So I'm going to be passing a struct again. So I'm going to be using it as a function. And they will pass the struct which is from counter event counter my back this kind. After increased and then remove this counter and value of by increasing 10 to 10. It's just the value of what 20. So this is panicking says expected variable constant found variance. So back here event counter increase. This is circle limited fix an array and then a token. Very from right. So counter if you go back to the documentation, it's how it helps us fix all this error. So by event checker, that's the name of their contract, right? The name of their contract is by event checker, and the event enum, then the first event, which is the struct, and some data is the name of their variable and the data type. So similarly, the pass the contract address, the name of the contract, the event enum, and the particular struct as a function, and then the event, the name of the contract, exposing the struct because struct is also public, right? And then some data. So we have to make sure this is public. Yeah, I think this is fine. Wow, so the test is now running inside the correct. It's actually running this event test that we just ran. I wonder why I didn't want to do this. But then let's finish with the event test. And I really hope this is not from the Cairo Web3. So let's try to get some kind of. So I just want to Scarb FMT, like this kind of like format to code in the right format. Maybe what I'll do is I'll just close my ID and open it again and allow the Scarb to things like phone. Because that really like also the issue. That's one of the things. So yeah, while we're on that, any questions concerning all we've done so far? So I'll just start getting your questions ready. Kind of structure and basic questions. So let's go for that one. So resolve. Any questions so far? Can raise hand, you can give a question in the chat. I'll come to answer the question now. And who else is following? Like who else is following on their devices? And are you facing any challenge? Are you facing any challenge? Try to replicate what you're doing here. Seems everybody was quite understand all what we've done so far. Right? Because I'll be asking questions at the end of the class. Scarb format. So you can see most of those one now just probably that is left. So sometimes it will be your Cairo one extension that was so you can either reload your case, just close the ID general and make and it should come. Speaking too long still. It doesn't always be like this. I wonder why. Just sites are top still. But then wait for that to be done. So as I was asking, yeah, I think somebody left a message in the chat. Somebody left any question. So yeah, I'll be asking my question. Ask my question really quickly. So first of all, a simple question. I'll need somebody to answer. Is why do we use a dispatcher? Because this is what like leads us to the next one we're talking about. Safe dispatcher. So why do we use a dispatcher? How does a dispatcher work? And tell me something about a dispatcher. Yeah, we use writing our tests. Right. I would have to select somebody to answer. Okay, you guys should want to select somebody. So yeah, most you know why I'm using dispatcher. I love learning this peak because like my best actually I'm not getting any response. I think people on this call please signify. So why is nobody answering? Yes, I just I have not gone over the save dispatcher yet. So that's why I'm asking what the dispatcher is before we move into what the save dispatcher is. How the save dispatcher works. Wait long. So that means can you tell us what dispatcher is? No idea. I don't think you in last time, but okay, let me know.
All right. Hello, can you hear me?
Yeah, I can hear you.
Okay. Well, the dispatcher, from my understanding, the dispatcher is when an interface is implemented through a trait. The Cairo VM creates a dispatcher that allows those functions to be accessible, since they are public functions, to be accessible from outside of the contract.
Yeah. So yeah, that's basically how dispatcher works too. Dispatcher just exposes the traits and makes it possible for another contract to interact with functions called in another contract. So that's how a dispatcher works. But then there's something else which is a safe dispatcher. Alright, a safe dispatcher is just like a safer way to work with dispatchers, right? take the same principle of how dispatcher works, but then in this case, it gives you the ability to undo errors, right? And errors the when calling functions from the contract. So, for example, now we know our should panic. We know how should panic works, right? It's just, for example, we know this is going to give us next track, right? And then it panics, right? What it does, panic literally just ends the function call there, right? So let me just try to differentiate between you should panic and how to save dispatcher. All right, hold on, save dispatcher. This should panic attribute literally just tells the compiler that okay, this code is going to fail. It's going to fail, but it's going to fail with this specific data. Right. So not like the test doesn't fail. The test fails, but because it's failing with a particular data, we can assume that okay, yeah, we knew about that failure. Like we knew it was going to fail like that. So that's why in our code it kind of like shows that it passes. But then in the real sense, the test actually failed. But the way to save dispatcher works, right? It gives us the ability to be able to handle scenarios, specific scenarios, in the test or the calling the contract into panic, right? So I'm going to be doing something like that immediately instead of talking to understand the problem right code. And also, if since my computer is kind of like taking some time on this, what I would do, I would use this code to tutor, and you guys can just run it on your system. Right? Is that okay? That's fine. Yeah, so you guys can run it on your devices and give me feedback instead of seeing that one. So yeah, let me do that. Go. This will be just so far. And then here if it's we're going to like fix that complete close. Who here knows how to work with it? That's beyond the scope of this. Okay. I remember. So yeah, I'll share the link to the YouTube. And you guys can just that.
Yeah, I can remember. It's more. It's more.
So yeah, we have that. So you can close that around the locally. Let's finish the result of this. So yeah, moving on, we're talking about the SafeDispatcher, right? And I was explaining that SafeDispatcher gives us a way to kind of like run a test, and it doesn't panic in real sense. It doesn't panic compared to should panic that actually panics, and then compiler just allows it to go scot-free after panicking. In this sense, it doesn't panic. It kind of like undo the scenario in specific scenarios when it panics, and then we can do something with that information. We can actually do something with that information. So let's do this. Let's increase seed panic using
Can you
seed
stop?
dispatcher.
Oh, good.
Seed dispatcher. And then, as usual, we can get all this. We don't need to.
Even if
Where I'm able to copy that, I just do Shift Alt and then down arrow key. I'm able to copy that information into that copy file. Okay.
What is the key combination again?
Shift Alt, hold down the Shift and the Alt key. Then you can press that down or up, depending on where you want to, or kind of duplicate code to. And then you can hold down your Alt key down to kind of animate the code down. That's just extra. So yeah. So now what we're going to be testing for, we're going to be testing for this panic, right? If amount cannot be less than 0, amount greater than 0. Okay, I think it's not better if we just run this. Okay, yeah, this is the simple panic data, because at the end of the day, when we are testing the panic, we have to test this particular panic data, right? We'll be using that, so I think that's shorter. So that's like the only reason why I'm using that. So like I can't just do that. So I'm going to be testing this as amount greater than 0. So so for us to test it to actually fail, right? So I'm going to be testing an amount of 0, right? 0 is not greater than 0. So if 0, if it puts in an amount of 0, but then amount is not equal to 0. We have to start testing this. Alright, so it's most likely going to be working for this assert. That's the only issue with having to assert. So yeah, we're going to use the first person. So quickly, let's talk about the SafeDispatcher. So how this works is the counter. So when you create a trait, right? When you create a trait, for example, the counter trait, the compiler generates two types of dispatchers. The counter dispatcher, like what we're using, and then the counter library dispatcher. Right, so how the difference between the two of them is that the counter dispatcher is used to interact with the contract using the contract address. So if you look at this, you can see that the contract address is passed. It's passed right here, right? It's passed right here, and then we can now use functions. We can now use functions from the contract. But if we're using the counter library dispatcher, instead of passing the contract address, we're going to be passing the class hash of the contract. And the class hash of the contract is what we get when we declare it. Right, so that's the difference between the counter dispatcher and the counter library dispatcher. And apart from that, it also comes with counter SafeDispatcher. Also comes with the iCounter save dispatcher. Similarly, the iCounter library save dispatcher come with that also. For in this case, we're just using the iCounter dispatcher since we're using the contract address to interact with this. Then once you use the iCounter save dispatcher, also use the response save dispatcher trait. Actually understand how to go. So, for example, assuming your traits would name something else like I woman, your compiler automatically generates dispatcher I woman dispatcher, I woman safe dispatcher. Right. That's how it works. Because automatically does that for you. So has anybody been able to run the test on their local machine? Just give me an update if you do that. The version of Scarb you're using. So right here now, if you observe this now, we're using the iCounter dispatcher. So instead of using that, we're going to use the iCounter safe dispatcher that we get. I'm going to use the iCounter safe dispatcher if our pass is the same contract address because right. So and then we are cheating if we have to cheat the contract, we need to call the increase counter function. But then there's something else I want to do. We want to be able to panic the contract, right? And then we're going to test that panic. So let's come back to the increase counter function. Right, so amount cannot be less than 0. So in the when we're calling the increase function, we're going to pass 0 as the amount, and we expect it to panic for this because the amount cannot be equal to 0, right? The amount we cannot pass an amount of 0. So instead of passing 10, we're going to pass 0, and doing that, you expect this panic, right? You expect this to panic. But then one more thing, if you carry this one in here, is saying using unstable usage of unstable feature save dispatcher with no feature save dispatcher attribute. So yeah, Cairo is warning us that this feature is not really good. So to use that feature, we have to like tag it with the feature save dispatcher attribute. So let's quickly do that. Under this, I'm going to add an action called feature and see someone got the message in the chat. Scarb YouTube learning. Also,
Yeah. That's the error I'm getting when I'm trying to compile.
can you share your screen?
Okay, let me try this.
Right. We're waiting. Are you there?
Yeah, it's doing it. Still thinking about it.
Yes, no.
Okay, I think we should just go ahead with
Okay, so are you seeing the screen? Okay.
Can I put
Do you see my screen now? Okay, share. Okay, okay, hold on. Is that working?
people? That's your screen.
Is it working?
No. I don't know if it's on my end. Can I use the screen?
No, I can't see it either.
Okay, you cannot see it. Okay. I think it's on my end. I need to authorize something somewhere. I think.
Right.
Maybe try
Does
sharing
anybody
your
else run-
entire.
Yeah,
Anybody
that's
else
what I
run
did.
the code?
Okay, allow.
Anybody else run the code?
Okay. That's it. Trying. Okay, let me try another time. This time we are sharing the entire screen. That's what it's saying.
Still can't see your screen.
Well, it's not working for me here. Unfortunately.
Right. That's fine. Did anybody else run the code? Yeah. Yeah, like 5 points score. Anybody else run the code? Let's know. Nobody. Show me. I think that error is from your Scarb programming, like your SM4 plugin.
Okay.
Try to if it's installed. Try running the same forge. But I think that's where the error is from. So somebody else to run the code. But then can you see my screen?
No. Yes, yes. We can see your screen.
Right, so I'll explain dispatcher or the safe dispatcher. So there was I was talking about passing the feature attribute, right? Since this is not a stable feature, it's a Cairo one. So we have to use like this feature attribute to be able to use safe dispatcher. Alright, so we pass the initial counter this. So yeah, she's giving us an error. But yeah, to fix that, the way safe dispatcher works uses a match keyword that calls the function. So you call the function using match keyword. And let's just name this, let's give this a different name. Counter safe dispatcher. So we know we kind of do like this, like using the safe dispatcher for this and not just our regular. All right. So the way it works, you call the function, all right, and whatever result you get from the function, the match keyword kind of like matches it to two values. So the way the save dispatcher works, uses the match keyword to match the results of the function you're calling, and that function can only have two results, right? So it's either it is an okay result. So an okay result means there was no error, there was no panic. Calling the function did not panic. So either it's an okay result or it's an error result. All right. So if it's an okay, we can now map a function. And map what should it do. Right. This is where it comes with handling the error case or the okay case with the match keyword. So it's going to give a kind of like a data that we can use. So give some kind of information. So here's how it works. We're using the save dispatcher. We have to actually put using the save dispatcher here. Using the save dispatcher imported. And then so to use the save dispatcher, we have to call the match keyword. And the way match works in Cairo, you can match it like this to the result trait. And the result trait has the okay and the error state. Right? So if calling the function did not panic, it's going to go with the okay trait. And then we can now do something with that. So knowing that our function to panic, right? According to our function, we want our function to panic, and then we can now undo whatever happens after the panic. So if our function doesn't panic, it's going to be going through this okay, and then we want the function to panic. So the way it kind of like what is, if the function doesn't panic, then explicitly tell it to panic. So we use the panic macro. Right, that's why I adding the exclamation mark. Let's use the panic macro, and then we can now keep a custom panic message. Right, a custom panic message is should have panicked since should have panicked counter is increased by 0, or I mean just going to get better, and let me just see divided counter is increased by 0. So yes, I need to panic this. So there's a comma slash right here, and then the reason why I'm using this underscore right here is because we are not really going to be using the information getting from the okay. So I'm not using that. So that's why I'm not naming it a particular variable. But then we want to make use of the error message, right? The panic data, and so I'm going to be giving it a variable name here. So the panic data, this is what we're going to be using to test our function when we call it with the save dispatcher. So we're going to take that panic data and then want to assert that, all right, our function gives an error, all right, panics, and when it panics with the particular panic data. And what's the panic data? From the increase counter function. The increase counter function, so what's panic is, right? Count amount are not equal to 0, right? Because we're passing an amount that is 0, and amount is not supposed to be equal to 0. So if you pass an amount that is equals to 0, it's supposed to panic with this. Right? So now we're doing the same dispatcher. Save dispatcher just helps us to be able to do this assertion without panicking the contract, or without the test panicking. But if you do that with they should panic, the test actually panics, but then it just the compiler kind of just understands that okay, we know it's going to panic, but then allow it to panic. But with the save dispatcher, the contract is not going to panic. Right? We just handle that safely. Right, so that's like the main difference between that. So the assertion is supposed to be the panic data should be equal to this, right? But then you have to snap the panic data. So this asterisk here is what's called the snap operator. What's called the snap operator. If you heard of the snap operator before, right? So the snap operator can only be applied on snapshots. So yeah, okay, why this is giving us this? Because the panic data is very an array, and it's supposed to be we're going to be getting the array data. The panic data acts the first item of the array. Right, so you can see that error is wrong. So let me just quickly explain this. Okay, let me complete the code. So if our panic data is equals to this, then it should just work fine. Else, we'll now add an actual panic data. So if our panic data is not equal to this, we can simply just return that panic data as a panic data. Right? This is not so complicated. It just sounds kind of complicated. Just so complicated. So we are literally just returning that panic data back. So this is basically all the code you need to. That is giving this warning, leaving panic in the code to destroy it. Because leaving panic in the code can end the or what they call it. It's just like a return statement, right? If you add a return statement in your code, once the compiler gets a return statement, it basically just breaks, right? It breaks the current instance of the code that is running, like it just kind of ends it. So the panic function kind of like does that, and the panic function panics without recovery. Like you can't recover from this from explicitly calling the panic function. So yeah, so let me go over this again. So to use the save dispatcher, you have to import the save dispatcher from the. You have to import the save dispatcher and the save dispatcher trait from the contract. Then pass the contract address and get the instance of the contract. Then cheating the contract to be able to call the increase counter function, because we use an aside only owner for that. And then calling this with the save dispatcher, we have to use the match keyword that matches that. When we call this function, it either panics. All right, okay, it either panics, and if it's panicking, it's going to be taking going to be passed to the error method, right? And if it doesn't panic, it's going to be passed to this is kind of like a callback function. That so when it doesn't panic, it calls this callback function is initiated, and if it panics, the callback function is initiated. So that's kind of how it works. Format string. String. So yeah, Did anybody understand how the SafeDispatcher works? Basically, how the SafeDispatcher works. But then, what is happening right here is we're taking the panic data, and then we are asserting that the panic data is usually given in a kind of like an array form, and taking like the first data is going to be panic data, actual panic data, and asserting that is equal to this. Else, we're trying to like return the actual panic data, but then the plugin keeps giving us this error that was not there before. Well, let me try something. Reload. Yes, I want to kind of resolve the code again without having to close your ID. So let's just pass the string argument. Because if you recall, this is actually a field. Our panic data right here is actually a field. So that could be why it's not. Let's try passing string. Let's say amount cannot be 0 if the amount so should have panic. Right, so the error is gone. There is gone. So I've been able to go through the SafeDispatcher, right? And has anybody been able to run the code? Has anybody been able to run the code? I think the code in the GitHub link. And I mean, have you checked your SFO version?
Yeah, I did. The SN4 version is the latest one, 0.40.0. You know, I updated it when I looked at your repository and your TOML file. I had the 0.38. I tried compiling with 0.38. It didn't go through. So when I saw that you upgraded to 0.40, I did the same thing over here, but still I wasn't able to compile.
Because your error seems to be coming from your SN4 Scarb plugin. So yeah, you can just share this in your hand.
So I was wondering whether maybe I should upgrade Scarb as well if there is a new version out there.
Yeah, what version of Scarb are you using? I'm kind of like using the latest
Scarb.
That's why I wonder why it's kind of still delaying on my end. I use like the latest version of Scarb.
Yeah, let me see. I think Scarb version. Okay. The Scarb version is 2.11.3.
Yeah, exactly. That's the latest
That's the latest one.
version I use. Yeah.
Okay, Cairo is 2.11.2 and Sierra is 1.7.0.
Let's go back here. So let me try something else. Let me try running another Cairo project. I know that's from the project or something. It's actually not. Okay, let me initiate a new tab. So the test is working. That means problems with it from our end from this. Because I created a new Scarb project, kind of like tests and test passes. So you remove the little of the body, find out why that is. And then the target back. After comment, stop macro. Okay, not I just use this drive. I will jump run directly. So trying to expose it. So we can do counter. I think it's the same thing. One last thing I'm going to do is I need to like move these files into the new project I created, which is test. So yeah, I've been able to go through testing events and using SafeDispatcher, right? So we are going to do a little bit of introduction post testing, and I really want to make sure that I'm answering any further questions, like any questions you have. So I've been mentioning it in the class. If you have any questions, please make sure to ask questions. Make sure to ask your questions. because it's very important that I can help you out while I can now. And also reach out to me on my social ways to help you out. Yeah, we can cover this. Counter to style. My skin kind of Cairo one is trying to resolve this. And then yeah, one of the reasons for this error is this Scarb return package is here. I think this is a and yeah, open Zeppelin. We're using open Zeppelin from our contract. So that against this. I don't think I'm missing anything else. See, I've changed this to counter. It's wonder why it's not updating. Let me just use this again. It has new folder. Import test. Then and resolve. I load the workspace. So yeah, one more time. Any questions so far? The master for wondering if you have any questions, okay, now I'm trying to migrate this to this. I believe I've done most of this fun stuff here. And get rid of this. Okay. Let's start around this. Oh, one was working fine. It's taking much time. So yeah, that's about working with sales. That's one of the things we wanted to shoot today. The syntax looks kind of scary, but it's not so complicated. Working with events also. Consider working with testing events and testing using SafeDispatcher. Let's quickly do something on first testing. So we can easily do that using instead of using this counter contract. Let's go back to our Cairo test. The first test we wrote, which was on our calculator, right? I said we're going to use that. So cd into that first test. I just need to go there and use our calculator to practice first testing. So basically, what first testing is, go to the documentation. First testing, there's also fork testing, but fork testing is quite, let me see, easy testing. So how fork testing works? Forks the state of a specified real network, right, and perform actions on it. So you can actually fork the state of Sepolia network, right? All you just need is to configure your code like this using those fork attributes, right? You can go to documentation, it's not so complex. So all you just need the fork attribute and pass in the URL of, let's say, an RPC for the Sepolia, and you can fork a particular block hash and then run your code using that particular state of the blockchain. You can fork particular fork testing. But then first testing, the way first testing works, first testing is a way to like generate random data that you can use to test your code or your function, right? For example, add function, you might want to test with adding a lot of numbers between 100, 10, and so forth, right? But then testing it manually can be so tiring. So you can use the fuzzer to perform this test. Right. So for now, it supports only a few types, which is the felt, U8, and byte. To use other types, you have to actually implement the fuzzable trait. And then, so let's quickly go back to our code. I think the first test is open. So we see our unit test like before. So we can just add a simple unit test to this and use the fuzzer attribute. Just leave that to compile. What is fuzzer attribute? And then test. Ideal. So function. What's the name of function? Let's see. Test the add function false. Right? Or let's say test the sub function false. Test sub false. Right? And then the way this works, we have to name a particular type of the argument that we expect the fuzzer to pass. Right? The fuzzer has to pass a particular type of variable. So our sub function actually takes two variable types, right? This is the 4. So we are expecting the fuzzer to generate random U64 variables. So we can just name that A U64 type and B U64 type. Right. Then we can pass that A, B, because that's the way our sub function works, right? Is anybody following? Is anybody following any reactions? Alright, so that's the way our sub function works. So I'm just going to create a function that takes two arguments, and those arguments are going to pass into the function. So the fuzzer is just going to randomly generate those arguments by itself that we can use inside our functions. So now what we can now do simply is, since we know our subtraction test is a simple test of just minus, so we can just use an assert. So assert macro to assert that the output of this function is the same thing as A minus B. But then, if the fuzzer, now you know the fuzzer doesn't know that what value should be greater than, like if we subtract a negative value using the fuzzer, right? Fuzzer can kind of like generate a bigger value for this A and smaller value from B, which will cause an error for us, right? That is one use case. But then in our function, we kind of did not handle that. So I think we just go with using the add function. But now we're just trying to test format string arguments. So yeah, let's use the quality. So I try to tell that this is going to be equal to this. Right? So basically that's how the fuzzer works. As simple as that. Please plugin diagnostic. This just has to do with the plugin. I don't think the plugin supports using fuzzer yet. That's even there. But this is simply how to write a simple fuzzer. But then we can even move forward to add like a particular attribute to our fuzzer function or to our fuzzer, which is the runs and the seed. So what this means is the runs kind of like tells the fuzzer how many times to run this function, right? It's different random periods. So if we do 3 times, so it's going to run this function 3 times with random variables. Now the seed, which could be any value, is just a way to track track the what do you call it? What the value that is passed, the random value that is passed. So now, if you put a seed of 45 to the fuzzer, right, it's going to generate random values for that fuzzer function that can be replicated, right? So when you put 45 when you put 45, it's going to create random values that we can replicate. Without the seeds, it just generates random value every single time. But with the seed value of whatever value you want to pass, right, and whatever, it helps us be able to replicate the result of running that fuzzer. Right. So let me just check our test. Still not compiled. I think maybe that's the ever comparing this world for the next. Then that has to do with the plugin.
Hello.
Yeah.
Yes. What I did for my problem here is that I reinstalled the Rust toolkit, and it seems to be going now.
Works. Okay, so you installed the toolkit.
Yeah.
I think I'm going to do that also. But then, so have you been able to run the test?
Well, it's going. It's actually downloading all of the Cairo stuff, compiling the different libraries for the moment. So it's doing its thing actually.
Okay, so you are still in the process of running the test.
Yes. So cargo build is actually working. It's no longer giving me an error.
All right. Awesome. So we're still doing minus when we have plus. That makes it. That's negative plus. So let's see. The reason I'm trying to run this with Cairo test, though I just want to find out if it works with Cairo test. Actually, this fuzzer, right, comes from the STRK foundry. So the STRK foundry library that actually implements this fuzzer attribute, right? Not the Cairo test. If you look here, you can see that the test runner is the Cairo test runner is the STRK foundry. But since STRK foundry has not been running on my machine, that's the only reason I'm doing this with Cairo test can run this. So yeah, I'll just add it to. I think I'll just do this. I'll add this file. I'll create the calculator file like I did before if I deleted it and add it there. Then push it to the repo so you can test it on your machine later. 2% forge. Not quite working. So who understand what I'm doing here? I need to get a response. Going back to the counter folder, and then I'll just add that for false testing. Right? I'll just add to simple Cairo program. Just calculator. Cairo. And then I'm just copy this. If we try to. So now we have our fuzzer and this. But there is also let me try to run this. Right. So one thing to notice, if fuzzer is generating random values, can generate very large random values, which would surpass Like now, if we add two random values that have a great, that are very large, right? It might, because we're expecting a return value of U64, it might exceed U64, U64. So you can positively use U256 and stuff. But that's the only reason why we're going to be getting that right, is because we're using the further. So I can just add this to the right or mode calculator. I'm spelling this right. So yeah, and I will use this new function. Plugin diagnostics, plugins being okay. I love Cairo English. Yeah, let me just try one more time. So run the test. I can't give up on running the test. Okay, wrong direction. Let's do this something. Now, so basically, we've covered most of the things that we are supposed to go through in this class of testing Cairo smart contract. So, any more questions thus far before I ask my question? Roundup of what we've done. We've tested, we've learned unit tests and how to write unit tests using the configuration attribute. Writing them in the same file. We learned a lot about using the assert macros, right? And we also learned yeah, and one more thing, let's see if the test is running. Function not found. At least the test run. That's a good thing. So A plus B, identifier not found, was, yeah, all right, that's no problem. So I'm going to be, let's try using the same identifier that was X, Y state. It's so nice. So yeah, one thing I wanted to point out is okay, I think we fix this. Add function, continue, yes. Then further attributes which are plugin does not stand. Save value. Start run that again. So yeah, let me as your Rust downloaded. So I was talking about what we've gone through in this class. We've gone through using assert macros and the further attribute generate random data testing, and also we went through a little bit of writing the counter, smart contract, and then wrote tests for the contracts, how to create demo contract address that you can use to test our smart contract. We also went through how to deploy the contract using the data function from the SNFOD standard library and serializing this data into the array so it becomes a sequence of fields that the compiler actually needs. Right, and then deploying using the class house method, still compiling Cairo models. Right. And also we tested using the assert macro. Also, we learned about using positional argument types in our panic data. And it seems everybody kind of like understand this. Any question about that? Any question about that so far? I want to get a response, like if you understand, give a response. So we've talked about positional arguments. Also talked about using dispatcher and using cheat codes, right, to cheat to run some tests, cheating the contract. There's a cheat code reference of all the cheat codes that we can use, that's provided by SNFOD. Using cheat code. It's down in cheat code reference. So you can always go to that reference. Always go to that reference if you want to perform some particular tests that require some kind of validation, right? Cheat code reference. We also talked about SafeDispatcher, right? Using the SafeDispatcher, and we also talked about using spy events. That's what we'll talk about today. To spy an event that is emitted from a contract. That's what we call a function. So all the counter of this function emits an event, and then you can use the spy that is gotten from the SNFOD library to assert that an event is emitted from the contract. And also we talked about the SafeDispatcher feature. We talked about the SafeDispatcher feature that we can use to retest from our smart contract without them having to panic, right? We test specific cases of smart contracts without, unlike they should panic. I mentioned the difference between the two of them, like how to panic, actually panic the contract, and then so any questions so far? If I ask my final questions for the night. Right, so I'm going to ask a bit of questions, and I'll need each person to like answer at least one question. Then, I'll find out what is wrong with the SN foundry library, and yeah, I'll mention that in the group chat. And also, if you experience that, like Lamin, I'll reach out to me. I'll figure out or discussing in the foundry library. Maybe it's the latest version that is kind of like having issues. I don't know. Yeah. So my final questions for the class is, first of all, somebody should tell me what the SafeDispatcher is and why we use the SafeDispatcher. Right? Quickly. SafeDispatcher and why we use the SafeDispatcher function. So I have to choose people. Okay, Rami.
Okay, I'll go. Okay, we use SafeDispatcher in situations whereby we know that we are going to get a panic, and we want to handle that gracefully. You know, that's when the SafeDispatcher comes into the picture.
Exactly. That's perfect. So that's when we use the SafeDispatcher instead of having the contract panic. We can handle the situation in which the contract panic. And then one more question is cheat codes, right? How does the cheat caller address work? How does cheat caller address work? Last question for the night. I'm calling somebody. Choma, how does the cheat caller address work? Choma, are you there?
Yes, I'm here. I
So
can't
did you get-
remember.
So who else can tell how the cheat caller address works? So I'm going to explain really quickly. It's not something so difficult, right? The cheat caller, it takes a contract address that you want to cheat, right? You kind of like want to pretend to the contract. You want to pretend to the contract about a particular thing, but in this case, it's a cheat caller address. We are trying to cheat the contract about who is calling the contract. For example, I'm not the owner of this contract, right? But I want to call this contract as the owner. So I'm going to be calling contract using the cheat caller address. So, and this is the address that is going to be calling the contract, the owner address. So what this owner function does, it literally just creates a address from the owner field. In the word owner, just generates a random address from that. And since that is what I use to construct to deploy this contract, right? I deploy this contract using the owner function. So automatically the owner function is the owner of this contract. So I can use the cheat caller address to cheat the contract into thinking that whenever I call this contract, I am the owner. Because in real sense, when we call this contract using the dispatcher, right? When you call the contract using the dispatcher, the SFO library just interacts with the contract itself. But when we check the caller address, the SFO library kind of like interacts with the contract using the address we used to cheat it, right? Using the address we passed right here. Right, so that's basically how the cheat caller address works. It just kind of pretends to the contract that a particular address is called the contract. So we can perform some tests. All right. So that's all about how the cheat caller address works, and we've been able to go through most of the stuff. I'm really sorry for my SM Foundry library is giving some issues. But then I always run tests on your local machine I'll push everything to the GitHub.
I have a question.
Yeah.
It's about the one kind of test. I think it's called forking test or fork test. Is that similar to? Yeah, is that similar to the cheater address?
No, not really, not really. Fork test, right? It just forks a state of the blockchain, right? Forks the state of the blockchain. The cheat color address just it doesn't use real data, right? Or the cheat codes don't use like real data from the blockchain. Do you understand? Right. So it's trying to cheat the cheat codes just basically. Let me show you from the documentation. Right. Using cheat codes. Codes that are dependent on a specific blockchain. Instead of trying to replicate, you can emulate them using cheat codes. So we are kind of like emulating the blockchain states, right? These are not real blockchain states. We are just emulating them using cheat codes. But in the fork test, support tests in a forked environment. So each test can fork the state of a specified neural network, right? So do you like understand the difference? Each test forks the state of a specified neural network and performs action on top of it. Right? I mean,
Yes, I get it. All right. So the fork is
right. So that's why I say you can always refer to the documentation. All this information is in documentation. So the forks specific neural network, right? Why the cheat code just emulates.
okay, it's clear. Thank you.
All right. Yes. So I think I'll be checking the question. Any other question so far? Right. Then no further questions. I think we come to the end of this session. Please, I'll be leaving my X handle. Reach out to me. I'll be happy to help. So, good night, everyone.